Hello guys, welcome back to my channel. Today we're going to be looking at factorizing quadratic expressions. Now, first of all, let us start at looking at what the general form of a quadratic expression looks like. It takes the form ax squared plus bx plus c, where a, b, and c are actually constants. Now, before we can understand factorizing or how we factorize a quadratic expression, we're going to have to understand expansion of brackets. So let me just put that in here. So let us say we get these brackets to expand 2x plus 3 and 3x plus 4. Now what we know is that all the terms in the first bracket will multiply all the terms in the second bracket. So let me start with the 2x. The 2x will multiply the 3x and the 2x will multiply the 4. So I'm going to have 2x times 3x, which is going to give me 6x squared. I'm then going to have 2x times 4, which is going to give me a positive 8x. I'm going to have 3 times 3x, which is going to give me 9x. And then I'm going to have 3 times 4, which is actually going to give me 12. Now, there is something unique about this expansion. So for instance, here we have 4 terms. Now, if I were to factorize this, because when you factorize something, you write it as a product of factors. If I were to factorize this, I would actually go back to the expansion here, and we can show you that. So let us say we decide to factorize. Let me just put that in there. If I decide to factorize, I'm going to pair them off. So for the first 2 terms, which are these, I could take out a 2x, which would leave me with 3x plus 4. For the second 2, which is 9x plus 12, I could take out a positive 3, which would leave me with 3x plus 4. Now, notice that bracket 3x plus 4 is common, so we could actually factor that out. So I have 3x plus 4, and then I'm going to have 2x plus 3 in the second bracket. And since multiplication is commutative, I could have turned this around, and I could have written 2x plus 3 times 3x plus 4. So notice we'd have gone back to this when we factorize these 4 terms. Now, let's look at a different kind of pattern that is also taking place here. Now, there is a relationship between the outer numbers, which are 6 and 12, which is also the same relationship between the inner numbers, which are 8 and 9. The question is, what is that relationship? Now, notice if I were to multiply 6 by 12, I would get 72. But if I were to multiply 8 by 9, I would also get 72. So what does that tell me? What that is telling me is that if we were to simplify this, so let me go ahead and simplify this. Let us take this over here. If I were to simplify this, I would have 6x squared plus 8x plus 9x, that's 17x, plus 12. Now, notice that when we multiply 6 by 12, we get 72. Also, when we multiply 8 by 9, we also get 72. So if I were to attempt to factorize this expression as it is, I would need to find 2 numbers that when I multiply them, since the outer values remain the same, those don't change. Those are what I'm going to have to use to tell me what I should get when I'm splitting the inner number, which is 17. Now, when I multiply 6 by 12, I'm going to get 72. So my task is to find 2 numbers that would multiply to give me 72. So 6 times 12, that is 72. I'm going to have to find 2 numbers that I multiply to get 72 to get the inner piece. Alright? But notice when I add them, I'm going to have to get 17x because 17x is what I need to split. So that is how the connection comes in. The outer numbers never change. So those will tell me what the product of the 2 inner numbers that I'm going to come up with should be. 6 times 12 is 72. So I need 2 numbers. When I multiply them, I get a positive 72, which is this here. But when I add them, I get 17x. Those 2 numbers I will use to split the 17x. So we say 72 has quite a few factors. So let us go, if we were to try to use 6 and 12. 6 plus 12 is 18. That's not giving me 17 because I can't change the value of a 17. Whatever two numbers I come up with, if I add them, I must get 17. Let's go again. We know that if we multiply 8 by 9, we also get 72. And if we add 8 and 9, we get 17. So those must be the two numbers. So what happens is that I would have to rewrite the 17x so that I can have those two terms. So we can factorize just like what we have over here being underlined. We're trying to go back to this. So we can say it becomes 6x squared plus 8x plus 9x plus 12. Now it doesn't matter which number I write first because as you know addition is commutative. Good. Now let's just see if the connection is there. Now 6 times 12 is 72. 8 times 9 is 72. And if we add 8 and 9, we still have 17. So we haven't changed the value of the expression. Now at this point, it takes us back to the step over here where we pair off the terms. So those two, and then we can factor out what is common between these two. So what is common over here? We have 6x squared plus 8x. What is common between these two, and let me just separate the space here, would be a 2x. Now if I factor out a 2x, I'm going to have 3x plus 4. In the second pair, which is 9x plus 12, we can factor out a positive 3, which is going to leave me with 3x plus 4. So notice now that if we look on both sides, the bracket as well as 3x plus 4 is common. So we factor out the bracket, 3x plus 4. That is inside of a bracket. What will be left would be 2x plus 3, which we can also turn around because of the commutative property. So with that said, what we try to do now is that we try to generalize this thing because this is just one question. And in order for me to develop this concept, I would have to do a series of questions. So we generalize this. So let us say we have, let me change the color here, ax squared plus bx plus c. Now applying the same concept that we use here. What we would have to do is start out by multiplying a by c, ac, because as we say, those numbers will never change. Just like how we have 6 and 12, all right? 6 times 12 is 72. So I would have to multiply a by c, which in this case, when I multiplied a by c, I got 72, which is 6 times 12. Now, whatever I come up with, I'm going to have to use it to split the middle term so I can end up with 4 terms, so I can pair them off. So we have to find two numbers that when we multiply them, we get AC, but when we add them, we get B. Because remember what is similar between it. If you go back over here on the left, remember we have 6 times 12, which is 72. And we also notice that 8 times 9 was 72. So that is what they have in common. But when you simplify 8x and 9x, you get 17. So you can't just look at the 17x and know that we're going to split it to get back 8x and 9x. We have to use the outer values that remain constant. So we have 6 times 12, which is 72. So I know that I needed to split 17x into 8x and 9x. So it's the same concept applied to the general expression. When I multiply my a value by my c value, please pay attention to the signs. Whatever value I get, I'm going to have to find two factors of AC. So if we multiply a by c, we get AC. So that when we multiply them, we have AC, which is the product. But when we add them, we should get B, which is inside here, the coefficient of x. Those two values are what we use to rewrite the B value. So we can have pairs to factorize, as in this case down here, where I group 6x squared with 8x and 9x with 12. That is the primary concept behind factorizing a quadratic in this form. All right, so we can look at it and then I'll create a video after this showing you some examples.